Here I'm going to be proving the angle addition formula for sine, which is stated as sine of x plus y is equal to sine of x times cosine of y plus cosine of x times sine of y. And to do that, I've drawn a picture of two triangles stacked on top of one another. The first being triangle ABC with angle y and triangle ADC with angle x. Now the triangle with angle x plus y is that ADF, and with sine being equal to the opposite side over the hypotenuse, we can see that that would be the line segment DF over 1, or just DF. We can then break DF into two smaller segments, DE and EF, but since EF is congruent to CB and CB will be easier to find, we can express that as DF is equal to the segments DE plus CB. Now we want to find the values of line segments DE and CB, and we do this by identifying as many sides and angles of these two triangles as we can. We'll start with the red triangle. First, we can look at the side DC, which is opposite to the angle x, and we know that taking the sine of x would be equal to the opposite side of the hypotenuse. In this case, would be DC over 1. So we can write that DC, the line segment DC, is equal to sine of x. We use that same logic for the line segment AC, which is adjacent to the angle x. Taking the cosine of x would be equal to the adjacent side over the hypotenuse, which in this case is AC over 1. So we can write that the line segment AC is equal to cosine of x. With that knowledge, we can move on and find the sine of angle y. The opposite side being line segment CB and the hypotenuse being cosine of x. And that can be rewritten as line segment CB equal to cosine of x times sine of y. Now that we've found one half of the proof, we can move on to finding the value of line segment DE. Now we know that the line segments AB and EC are parallel, and that the line segment AC is a transverse, meaning the angle y at CAB is the same at the angle ACE. Now if that's y, and we know the angle DCA is a right angle, then the angle DCE is equal to 90 minus y. And if the angle DEC is equal to 90 degrees, and those two angles add together to make 180 minus y, and the total value of all three angles in that triangle must be equal to 180, we know that the angle ADC must be equal to y. With that information, we can take the cosine at angle ADC, and that being the cosine of y, we find that it's equal to the adjacent side DE over the hypotenuse sine of x, which can be rewritten as DE is equal to sine of x times cosine of y. Now with all that put together, we can rewrite this as sine of x plus y equal to sine of x times cosine of y plus cosine of x times sine of y.